بسم الله الرحمن الرحيم. أسعد الله صباحكم. نبدأ اليوم إن شاء الله recording. We are going to start our recording for section 7.3, which is the eigenvalue method to solve linear system. First of all, what's our linear system? If we have a system of equation like dx1 with respect to t is equal to, let's say, 4x1 minus 3x2, and dx2 with respect to t is, let's say, 3x1 minus 5x2. This can be written as x dash, where x dash is the column vector dx by dt, dx1 by dt, dx2 by dt, and our A is the coefficient matrix, which is 4 minus 3, 3 minus 5, and our x will be just simply x1 and x2, so we can write it in this form. Our independent variable always t, that's why we will say there is a solution, which is the eigenvector times e to the power the eigenvalue. That's what we call it, a solution of the linear system, which is a generalization of what we have done in section 5, which is 5.3, which is homogeneous differential equation. So if I have different eigenvalues, we will have different eigenvectors, and our solution will be simply the sum of all solutions. So we will start with finding the eigenvalues, which we discussed it in section 6.1, 2, and 3. So then once we find the eigenvalue and the eigenvector, this will be the general solution of the system. Okay, now let me erase this one. It's supposed to be clean. Why it's not cleaning? Anyway, let me forget about that one. Okay. Let me open another one. I will run a new section. Let's grab this one. Okay. Close this. Okay, let me open it from here. Open. Okay, this one. Section 7.3. Eigenvalues. Okay. Run. Okay. Okay, I hope this is a clean one now. Okay, matrix. Now, let's start our first example about solution of a system using eigenvalue method. Now, first of all, step 1, we define we write our constant matrix, which is 4, 2, 3, and minus 1. And first step, step 1, use A, which is equal to 4, 2, 3, minus 1, to find eigenvalues and eigenvectors. Okay, so we have to solve for eigenvalues a minus lambda I equal to 0, as we said in section 6.1. So that will be 4 minus lambda, 2, 3, and minus 1 minus lambda equal to 0. That is 4 minus lambda times minus 1 minus lambda minus 6 equal to 0. So that will be 4 times minus 1 is minus 4. 4 times minus lambda is minus 4 lambda. Minus lambda times minus 1 is plus lambda, and minus lambda times minus lambda is lambda squared equal to 0, which is lambda squared minus 3 lambda. We have here, we should not forget minus 6 minus 10 equal to 0. So when we factor this one, we get lambda times lambda minus 5 times plus 2 equal to 0. So our first eigenvalue is minus 2, and our second eigenvalue is 5. Now, for the first eigenvalue, which is equal to minus 2, we solve for eigenfactor. That is, we need to replace here. Lambda is minus 2, it will be 4 minus of minus 2 is 6, 2 on the right hand side is 0, that is a 3, minus 1, minus of minus 2, plus 2, so that will be plus 1 and 0. Now, if we divide the first row by 6, we get 1, 1/3, 0, and this is 3, 1, 0 as it is. Now, this is a leading term, so we can use it to make the elements below to 0 according to echelon form. So minus 3 row 1 plus row 2. If you multiply row 1 by minus 3, you get minus 3 minus 1 0. When you add it with 3 1 0, you will get the entire row is 0. Therefore, we have k1 plus 1/3, k2 is 0, which means k1 is minus 1/3 k2. Therefore, we say now choose k2 to be minus 3, so we get k1 will become 1. So our eigenvector will become 1 and minus 3. Similarly, for the second one, for lambda 2, which is equal to 5, we need to solve for the eigenvector. So if I replace here by 5, I'll get 4 minus 5, which is minus 1, and that's 2. And that is 3, and minus 1 minus 5 is minus 6. Same story, to prepare that one as a bifid, we multiply row 1 by minus 1, we get 1 minus 2, 0. And that's as it is 3 minus 6, 0. Then I will use the leading term, which is 1 minus 2, 0. The leading row will be used to make 3 0, so we will say minus 3 row 1 plus row 2. And if we multiply row 1 by 3 only, 3 row 1 plus row 2. So 3, it will be sorry, again, it's minus 3 and 3. I'm looking up. Minus 3, 6, 0. 3 minus 6, 0. I will get the whole row is 0. So I will have k1 minus 2k2 is equal to 0, which means k1 is 2k2. So choose k2 to be 1, k1 will become 2. So our eigenvector will become k1 is 2, k2 is 1. Okay, now we have now an eigenvalue and an eigenvector. So we will say the solution of the linear system is, that's step number 2. That's actually the only idea in this section. It will be x of t, which is c1 e to the power lambda 1, which is minus 2 t, and the eigenvector of the first one, which is 1 and minus 3. c2 e raised to the power 5t, and the eigenvector, which is 2 and 1. That's all. That's the only uh, added step. Now, number 2, here I said we need to find the eigenvalue and corresponding eigenvector of the constant matrix A, which is 2, 3, 2, and 1. So we are going to solve A minus lambda I equal to 0. That is 2 minus lambda 3, 2 and 1 minus lambda, and that will be equal to 0. So I will have 2 minus lambda times 1 minus lambda minus 6 equal to 0. So it will be 2 minus 2 lambda minus lambda plus lambda squared minus 6 equal to 0. So I'll have lambda squared minus 3 lambda. 2 minus 6 is minus 4 equal to 0. So we can say it's lambda times lambda, and it will be minus 4 times plus 1 equal to 0. Okay, so we have two eigenvalues. The first eigenvalue is lambda 1, which is equal to minus 1, and the second eigenvalue is 4. So we do the same thing now. We solve for lambda 1, which is equal to minus 1. Find the eigenvector. So I have to replace here lambda by minus 1. So I'll get 2 minus of minus 1 is a 3, 3, and the right hand side 0. That will be 2 minus of minus 1 again, 2 and 0. Actually, you can see it clearly. It's actually the same equation. But anyway, if you divide by 3, you will get 1, 1, 0. And that's 2, 2, 0. And we can say this is 1, 1, 0, that's leading, and we will say minus 2 row 1 plus row 2. You will get the whole row 0. So we will get k1 plus k2 is 0, which means k1 is negative K2, so choose K2 is equal to minus 1, K1 will be 1, so our eigenvector for lambda 1, it's 1 and minus 1. We do the same for lambda 2, which is equal to 4, so we will solve for the eigenvector 2 minus 4 is minus 2, 3, and the right hand side is 0, that is 2, 1 minus 4, it will be minus 3, and that is 0. Now, we can say, by the way, immediately here, I can say this is equal to minus 2, 3, and the right hand side 0. I will just say here R1 plus R2. If we add them, that will be 0, 0, 0, which means I will have minus 2K1 plus 3K2 is 0, which means 3K2 is equal to 2K1, which means divide by 2, I will have K1 is 3 over 2K2. So if I choose K2 to be 2, K1 will be 3, and our eigenvector, it's K1 is 3, K2 it's 2. Okay, so if I choose K2 is 2, K1 will be 3. Now, once we get that one, so our next step, which is the only idea we have today, that's all from section 6.1. We will say the solution of the linear homogeneous system as x of t, which is c1 e to the power lambda 1, which we say lambda 1 is minus t, and the eigenvector, which is 1 and minus 1. Same thing here, c2 e raised to the power, our second eigenvector is 4, so it will be 4t, and the corresponding eigenvector, which is a 3, 2. That's the whole thing about this section. Again, I made find a general solution of the linear system. We are repeating the same idea. So our first step, we will say find the eigenvalue and corresponding eigenvectors of the matrix A, which is the constant matrix 3, 4, 3, 2. So we will say here A minus lambda I equal to 0. So we will have that as 3 minus lambda 4, and 3 and 2 minus lambda equal to 0. So we will have 3 minus lambda times 2 minus lambda minus 12 equal to 0. Expanding 3 times 2 is 6, 3 times minus lambda minus 3 lambda minus 2 lambda plus lambda squared minus 12 equal to 0. So we will have lambda squared, I will have minus 5 lambda, 6 minus 12 is minus 6 equal to 0. We factor lambda times lambda, and that will be minus 6 times plus 1. So minus 6 lambda plus lambda is minus 5 lambda. So our lambda 1 is equal to minus 1, and lambda 2 is equal to 6. By the way, if you are not good in factoring, you can say lambda is minus b plus or minus root of b squared minus 4ac divided by 2a. You can find it using the quadratic formula, but usually we give you something which is easy to factor. Now, we do for each finding eigenvector. So for lambda 1, which is minus 1, we start with our matrix. Replace minus 1, you get 4, 4, 3, and 2. Minus of minus 1, again 3. And you can see these are actually the same ones. So if I divide by 4 the row 1, I'll get 1, 1, 0. That's a 3, 3, 0, and I can use the leading now, which is 1, 1, 0. I will say minus 3 row 1 plus row 2. So I'll get 0, 0, 0. So we will have K1. So I will have here K1 plus K2 equal to 0, which means K1 is negative of K2, and we choose K2 to be minus 1, so K1 will be 1, and our eigenvector will be K1 is 1, K2 is minus 1. Same thing we do for lambda 2, which is equal to 6, so we are going to solve 3 minus 6 is minus 3, 4, and 0, and that will be 3, 2 minus, which is 2 minus 6 is minus 4. Clearly, I can say immediately, actually, I can say this is minus 3, 4, 0, and if I add just row 1 plus row 2, if I add these minus 3 plus 3, 0, 4 minus 4 is 0, so I'll get minus 3 K1 plus 4 K2 is equal to 0, which means 4 K2 is equal to 3 K1. So divide by 4, you will get K2 is equal to 3 over 4 K1. So choose K1 to be 4, K2 will be 3. So our eigenvector is 4 and 3. That's all. So our next step now, step 2, that's the only idea in this section, is the solution of the linear system as x of t, which is c1 e to the power lambda 1, which is minus 1, so it will be minus t, the eigenvector, which is 1 and minus 1, plus c2 e to the power lambda 2, which is we have 6, so it will be 6t, and the eigenvector of 6, the eigenvector is 4 and 3. Okay. Now, same story, but it is actually of of a matrix of the form 3. So our first step, find the eigenvalue and eigenvectors. So that will be for the matrix A, which is defined to be 4, 1, 4, 1, 7, 1, 4, 1, 4. So we will solve again A minus lambda I equal to 0. That is 4 minus lambda 1, 4. That's 1. 7 minus lambda 1. That's 4, 1, 4 minus lambda equal to 0. So that will be 4 minus lambda. The minor of that one, it will be 7 minus lambda and 1, 1 and 4 minus lambda. Now, the location is minus, the element is 1, and the minor of 1 will be 1, 1, 4, and 4 minus lambda, plus 4, and the minor of 4 will be 1, 7 minus lambda, 4, and 1 equal to 0. Now, that will be 4 minus lambda, 7 minus lambda times 4 minus lambda minus 1. That's minus 4 minus lambda minus 4, and that's 4. 1 minus 4 times 7 minus lambda equal to 0. We simplify this one. We will say this is 4 minus lambda. If I expand this one, 7 times 4 is 28. Then 7 times minus lambda is minus 7 lambda. Minus 4 times lambda and plus lambda squared minus 1. And here I have plus 4 minus 4 is 0, so I'll just have lambda. And I have here 4 times 1 minus 28 plus 4 lambda squared. And that will be equal to 4 minus lambda times, here I will have lambda squared minus 7 plus minus 4 is minus 13 lambda. And 28 minus 1 is 27. Okay, here I have plus lambda, and here we will have, here I have lambda plus 4 times, I will have here, I will have here 4 lambda squared minus 27. Now, okay, so would it be possible to get an, we call it a common factor? Let me see. Let's expand it and see what will happen. What I will have here, if I expand, 4 times lambda squared is 4 lambda squared, and 4 times minus 13. Let me use the calculator to make life easy for me. Not any calculator here. Yeah. Okay, so I'm expanding. 4 times lambda squared is 4 lambda squared, then 4 times minus 13, that's minus 52 lambda, and 4 times 27, it's 4 times 27 is 108, then minus lambda cubed, which is minus lambda times lambda squared, plus 13 lambda. Then I will have minus, it will be minus 13 lambda squared. Then I will have minus 27 lambda. That's expansion of the first one. I mean, this is the expansion of that one. Now, I have here plus lambda plus 4 times 4 is 16 lambda squared, and 4 times minus 27, we just said 4 times 27, that's minus 108. Okay, equal to 0. Now, let's start from the largest one to the lowest one and combine the similar ones. I have minus lambda cubed, okay, and I have for lambda squared, I have here plus 4 lambda, so I will have 4, and I have here plus 13, and I have plus 16. So is it? Okay, let me see if there is any. Okay, I will have here 4. Okay, and I will have minus times minus will be plus 13. That is okay also. I have here 16. Okay. Anyway, let's see what will happen. That will be 32 lambda square. Then I will have for lambda 2, which is this one, and I have minus 27. Okay, what else? That's what I have. So that will be minus 79 lambda. That's very unusual. Seems to me there is an easier one. Okay, and we will have for lambda I have, this is plus lambda. Oh, I have here plus lambda also. So I have minus 52 minus 27 plus 1, that will be 78. Okay, what else I have? I have 108 minus 108 will be 0. Now that's all, I guess, equal to 0. So if I take minus lambda common factor, I will get lambda squared minus 32 lambda, and that will be plus 78 equal to 0. Okay. Now that will be either lambda 1 is 0, or we have lambda squared minus 33 lambda plus 78 equal to 0. I'm just having about okay. I think there is an easier way to simplify this one. Let me try another way to simplify it. Before we continue, I have a doubt there is somehow arithmetic mistake. So let me redo the calculation again. Let me just do the simplifying. I will do it again in another way to avoid this type of silly mistake. What I have here, it's 4 minus lambda and 7 minus lambda 1, 1 4 minus lambda, that is okay, minus 1, that is 1, okay, everything is perfect now. So I'll say this is 4 minus lambda. I will say 7 minus lambda times 4 minus lambda minus 1, and here minus, I will have 1 times 4, 1 times minus lambda minus 4, again that will be plus 4 minus 4, 0, that will be 4 times 1 minus 28, 4 times 7, which is, and 4 times minus lambda. So what I will get here, I will say if I expand this one, I will get 7 minus lambda times 4 minus lambda all squared, and I will have minus 4 minus lambda, which means if I multiply by minus, it will be minus 4 plus lambda. And here I get now plus lambda squared, and here I have 4 times minus 27 minus 4 lambda equal to 0. Now this will be 7 minus lambda, and that will be first squared, which is 16, minus 8 lambda plus lambda squared. I have here minus 4 plus lambda squared minus, that's 27 times 4, that's minus 108, and minus 16 lambda. equal to 0. Now if I expand, I'll get 7 times 16, 7 times 16, that is 112, and 7 times minus 8, it's minus 56 lambda. 7 times lambda squared, 7 lambda squared, and I have minus lambda times 16 minus 16 lambda, minus lambda times minus, that will be plus 8 lambda squared, minus lambda times lambda squared minus lambda cubed. I have here minus 4 plus lambda squared minus 108 minus 16 lambda. Now grouping the similar ones, I have minus lambda cubed, which is this one. Then I have lambda squared, I have 7 here. I have here 8, that's 15. And I have here 1 is 16. And we have here minus 16. So I will have, I have, let's say, 7 plus 8, 15. 15 plus 1. Okay, it will be 15. So that's just 15 lambda squared. Okay, it's I'm adding it with something else. Okay, so I have 7 plus 8, which is 15, plus, so that will be 16. Am I right here? Lambda squared. Do I have lambda squared here? Yes. From where we get this lambda squared? There is no lambda squared here, is it? Okay, that is that one. That's not lambda squared actually. I have minus of minus will be just a plus lambda. There is no lambda squared. So, okay, that's the mistake. Okay, that's what we have here. 7 minus lambda times that one, and 4 minus 4 plus lambda. And here I have minus of minus will be plus lambda. And I have 4 times minus 27 minus 4 lambda. That will be okay. That is now okay. And I have here minus 4, it's not lambda squared here anymore. It will be lambda plus lambda minus 108 minus 16 lambda. Okay, so let me remove this one now. We need a bit concentration. We say 7 times 16, that is 1, and I need 7 times minus 8, 56 lambda. 7 times lambda squared, 7 lambda squared minus 16 lambda plus 8 lambda squared. Okay, and minus lambda cubed. That's the first one. Here I have minus 4 plus 2 lambda. Okay, and I have here minus 108 minus 16 lambda equal to 0. Now I will group the similar ones. So I have, first of all, just minus lambda cubed, and for lambda squared, I will have here 7 plus 8, which is 15. So that will be 15 lambda squared. Then I have here, for lambda, I have minus 56. Okay, so minus 56 and minus 16 What else I have? Plus 2 and minus 16. Okay, let me double check. I have minus 56, minus 16. Okay, why that is it's supposed to be 15, then this equal 54. Okay, minus 6. Okay, plus 2 lambda. Why did we say 16 lambda square there? Anyway, mistake. Anyway, we are right. So we have minus 56, minus 16, okay, plus 2, minus 16, that's minus 86. It's minus 86 lambda. I hope there is no mistake. What about the constant? I have, for the constant, I will have, which is this one. Then I have here minus 4, and I have minus 108, and that is 0. So that will be equal to 0. Now, taking the minus lambda common factor, so that will be lambda squared minus 15 lambda plus 86 equal to 0. Anyway, so either lambda 1 is equal to 0 or lambda squared minus 15 lambda plus 86, numbers are not good, is 0. We can say lambda is equal to minus b, which is 15, plus or minus root of 15 squared minus 4 times 1 times 86 divided by 2 times a. So our lambda will become 15 plus or minus, anyway, I'm not going to give in the final something too strange like this one, 15 squared minus 4 times 86. Okay, 15 squared minus 4 times 86. Anyway, that will be a complex values. Okay, I'm not interested in complex values, just forget this one. Just ignore it. We are interested only in distinct linear. Now, unless I have done arithmetic mistake, anyway, that's not suitable for our final with this category. Okay, we will focus only in distinct eigenvalues, not complex eigenvalues. Okay, that's all for this section.